guys, welcome to this video where we're going to have a look at the idea of integrating the exponential function. So what is that referring to? Well, I've got just as it says here at the moment, the exponential function is y equals e to the power of x, and what we're trying to find out is what is this integral of e to the power of x. And later on we'll have a look at situations that are a little bit more complicated than that. So to begin with, let's remind ourselves of a couple of things. If we have a function and we use the process of differentiation, we obviously get the derived function. And if we want to go from the derived function back this way, we need to use the process of integration, which is also sometimes called anti-differentiation, because it's the reverse of this differentiation process. So why am I talking about that? Well, one of the things that we saw when we did the work on differentiation is that if we had the basic exponential function, if we derive that with respect to x, we also got e to the power of x. So if this is e to the power of x and the derived function is also e to the power of x, I think it stands to reason is that if we go back this way using integration, then we're simply going to be getting e to the power of x again, which is what in fact is the case. So to answer the question, what is the integral of e to the power of x with respect to x? It's itself, with, let's not forget, that constant of integration. Okay, so why that constant of integration again? If you had a exponential function like this with some constant, okay, which might be -3, or it could be any other number you like, if you differentiate, okay, you derive e to the power of x as itself, and the derivative of a constant is 0. So if we come back from here to here using integration, we won't know what that constant was because it's disappeared over here. Okay, so if we're trying to then integrate the basic exponential function, okay, bearing in mind about that discussion we just had with regard to the constant, the best we can say is that it's going to be itself plus some constant that might have been there at the beginning that when derived disappeared. So when we integrate, we simply indicate a constant that might have been there even if it was 0. Okay, let's have a look now at a slightly more complicated situation, and what we're going to do is have a look at what was the derivative of a exponential function where there was some constant here in front of x. Now you might recall that when we derive that, okay, then we're going to get the derivative is going to be, well, using the chain rule, it's the same exponential function times the derivative of this part, which is simply 3. So we get 3 e to the power of 3x. Okay, so the question is, well, what then would be the integral of e to the power of 3x? Okay, well, if I simply say, well, it's going to be the same exponential function, okay, if I say it's this plus a constant, well, we run into a problem. We've just seen that the derivative of this is 3 e to the power of 3x. So this can't be the correct answer. Looks like we're out by a factor of 3. So what happens if I said, okay, let's put 1 over that constant here in front? Would that be the answer? Well, let's check. We should be able to check to see if this is the correct integral by deriving this, and we should get back to this one. So let's do a little checking process. If we had this and we derived, okay, then yep, we'd end up with 1/3 e to the power of 3x times 3, chain rule again. The derivative of the constant would be 0, so that would disappear, and sure enough the third times the 3 becomes 1, so yeah, we do get e to the power of 3x. So it looks like this is the correct answer for the integral of e to the power of 3x. Okay, so taking perhaps just another example, if I want the integral of e to the power of, say, negative 2x with respect to x, and I should have had that up here too. Okay, then I think, bearing in mind this discussion we've just had, our answer might be 1 over negative 2, or in other words negative a half, e to the power of negative 2x plus c. Okay, what we need to do is to check to see if that's true. We can check it by deriving this. Hi guys, we're going to give you a couple of problems now to have a go at. So this will be the first problem. So I'm just going to let the camera run for a few moments while the problem appears. Okay, and then we're going to have a go at the second problem, which should be appearing about now. Okay, good luck with those.